who wants to share first? You finna do it, Carson? You gonna share first? All right. All right. So let's take a look. We're waiting on Mr. Carson. All right, he's sharing. So let me switch gears. Okay, hold on, Tashawn. I'm trying to catch up to you. I got the right screen. And let's take a look at what he did here. All right, so Tashawn, you gotta show me the right screen. It says Carson, because in there it is. All right, any questions there? That's it right now. Oh, here. Fundamental theory, quantify. $150,000 to be doing what you guys are doing, which is calculations and robotics, drones, engineers do a lot of programming. Let's start this out, right? And we go up, the more years and more certifications you get. You can start sharing that 15 additional points, Mr. Carson. Ms. Medina, what do you have? Can you share your screen? The law states that at any certain junction, some currents flowing into and out of that junction. Now, you have a pretty good answer, a very good answer. She got very, very technical. While the apostolic electrical per year, a strong engineer salary for college grads, and the top 25% earn about $104,500 per year, but the average salary, engineer salary varies by location. 15 extra points, Ashley, great job. Alika, my Belizean friend, what do you have to share your screen?
You got to believe.
You told me that.
I've got to see.
Okay, here we go. So let's see what Alika has. She put perfect boom from security to quantify how current flows your circuit and how voltage varies around a lumen circuit. It is an application of the principle of conservation of electric charge. The law states that at any circuit junction, some of the currents flowing into and out of that junction. Someone else had that answer. And then what Alika for part B said, the average salary for an entry electrical engineer is about $68,288. Experienced electrical engineer can make about $99,039 a year. Pretty good. 15 points, girl. All right, we're going to jump into our simulation piece. You might want to hurry up and open up your circuit construction kit. Now, this is going to be a little easy today because we're doing just parallel. I'm going to erase this, and I'm going to draw what you have to do on the board, okay? So let me do this so you can see it can be recorded. I know I can do this now. And we're going to go ahead and pin this right here. All right. So let's turn this way. This is the first time testing out. So last time we had, I think Facebook is still connecting the shared screen. I was testing something out the other night. Yes. So you can see digitally out of two cameras. And you guys can look on your Google Meet to track what I'm doing. You just go to this screen here. You work on the board, right? So here's a circuit you have to create.
Yeah.
Here's a eraser.
They say this respect the page and how we found.
This what?
This respect the page and how we found.
You talking about for the circuit?
For my simulation.
Oh. The link is not working? Huh? I don't know what you're talking about. What's going on? So type in your search bar real quick. FET sim. No, I'm good, babe. I can't do candy.
You guys want a subject? Can I have one?
So here, I'm gonna put the link in the chat for you guys in Google Chat. Okay,
But they're organic, so I'm like,
All right, so guys, go to your Google chat real quick. And do y'all see that? It's a message I put in the Google Meet for you. Try that link out. That's the link y'all signed that'll work. All right. Well, I think that's what Carson was telling me. I don't know. Did you click on that chat? All right. So look, we're recreating this circuit here, right? So we're going to have an electromotive force. What's you say? Junction point, resistor. All right. Junction point. Coming over. We're going to have another resistor there. We're going to come over again. Junction point. Down. We got 3 resistors. So another junction point. All right, I'm showing you what you're going to recreate in a moment so you get started. And then we're going to have another junction point for a light bulb. We're going to call this light bulb over here. So, bulb. Okay. Right? And we're going to come down. And, okay, these are connection points for the light bulb. Right here, don't forget you have something called a switch. Alright? Switch looks like this. Leave your switch open. Don't be like Tyshawn closing the switch in advance, okay? Leave it open. And this is your, of course, your R1, your R2, your R3.
Hello, resistance.
Yeah, we did blueprint mode. You should know about that.
Is a battery, right?
Well, this is your electromotive force, right?
That's the battery.
Yes, yes, electromotive force. I'm trying to get you to see the technical term. You just countrified with it. The battery. This is the battery. Electromotive force, right? Leave this as a regular battery. Do not use a high power battery. Okay? So your regular battery should start with 9 volts. That's if you're using a regular battery, not the 1,000 volts. That's a lot of power. These are regular resistors today, okay?
Are you using real battery?
I just said regular battery, baby. Yes, I said a regular battery. All right. Copper top. It's like, you know, the Duracell copper top. All right. Rolling black. Anyway. Okay. We got this. Don't forget over here, we need something called a fuse to protect our circuit. Yes, you guys are working as engineers now, but you're not looking at cartoon versions. You're using what engineers and technicians use. Actual blueprints, right? So this is what we call your fuse.
Oh, regular resistance.
Oh, extremely. Yes, use regular resistors. Okay? Not high power resistors. So those are the ones with the bands of colors.
Yeah.
So this is a fuse. Okay? So now you need to be programming this, switch screens, and show you how. Okay? So all I'm gonna do is.
A regular resistor?
He just said that, y'all. What are y'all doing? So once we calculate all this, we're gonna have a new circuit that looks like this. Okay? There'll be 1 resistor there. So your REQ. You understand what you're doing? Come over. Of course, the bulb is still connected.
Yeah, like that.
And then you're going to have an ammeter, of course, right here, right? Don't forget it's a switch right here. So this is what happens when we do the calculation. Okay? Just wanted you to see what you was doing. All right, mister, I'm going to wait on you. All right, let's jump into the simulation piece. I'm going to switch screens now. You might be, but just do what I do in case you don't know. Okay, I'm going to come here. I did that for 10 minutes, so we got to be quick because we got some math to do next. So let's try to do this as fast as we can. We got 2 screenshots. Let's rock and roll. So if you're not sure how to get back to the simulation, you can always just type in up here, open a search, PHET for FET. Simulations, and circuit construction kit is the one you want. Okay. All right. Now, make sure if you get this screen, hit the play button, and we're into our lab, not intro. Intro doesn't come with all the tools you need.
Can you put that ad up?
Can I what? Oh, I gotta change screens for y'all. Yes, I'm about to, hold on, because I just saw it wasn't set up right. So let's put this up here for you. All right. There we have it. Everybody's great now. You want the big screen. There we go. All right, so follow along. And if you can't see what I'm doing, of course, just go inside of your Google Class. You'll see everything. Okay, so now that we got that out the way, let's move to the circuit. Everybody's on the blue screen like I will be in a moment. And we're just recreating that top circuit there. Remember, when we get done calculating everything, it'll be that smaller circuit you saw a moment ago. So turn on your values, click Advance, make sure you add a real bulb. Next, let's build this circuit we have on the side. So I'm going to start with a regular battery. Let's go up top. Gold and black, right? The real light bulb, yes ma'am. It goes where I have in my drawing over there. You need a wire. And I'm going to slow down here because this is the part where we put in a switch, right? Okay. Next is leave your switch open. This is what Mr. Carson doesn't do. He blows the circuit up. Grab another wire. And then we're going to grab a wire and make our first junction point. That's where I have the circles on the diagram, right? And grab a resistor, a regular resistor. A regular resistor has bands. This is how you can calculate what the resistance value is. Grab another one. Okay? And just because I want you to see a difference, we're going to put an ammeter on each branch. Okay? So you can see the difference in the currents. All right, so far so good. Now we're going to do this for 2 more branches. Another wire. Resistor. Hope we're keeping up. What's going on, Lika? Okay, another ammeter. And wire. Uh-oh. Okay. And another resistor. All right. So far, so good. She said, I guess. Okay. So far, so good. Getting close to the end of the circuit. You're going to slow down right here because you got to put a fuse in there, right? This protects our light bulb. So at this point, we're going to grab the fuse. I'm not moving fast. I'm just focused. I'm working on the topic. Y'all talking about life. Y'all be thinking this social hour. You look up. That happens in college, too. I learned it the hard way. You're chilling with all the Asian people, all the white people, and, they'll talk to you, but they'll be doing their work. You look up, and time pass, and you can talk yourself to death, and they done with their work. You up there bumping your gums, as my dad would say.
Hey, I heard
Running your mouth.
I heard if you get caught cheating in college, they'll kick you out.
Yeah, they sure will. It's called expulsion, sir. You thought it was sweet. All right, so yeah, well, you go ahead and try that if you want to, because in college you paying for it.
Kick me out. Yeah, I'll kick me out. I ain't walk out.
Okay. You get that bill. You're gonna be feeling salty. Yeah, they're gonna finesse you back because y'all be trying to finesse too. All right, so I'm almost through. I think at this point, I want to put a current probe down there. So let's connect that. Everybody keeping up with me?
You just said you messed up.
Oh, she said she fixed it. She too smart for you? All right, I'm almost through here. And this last port is going to be to our bulb. So you should have what I have, or just about. A little crooked. Crooked eye, I forget what is it. Crooked letter. All right, anyway, that's a song actually, but yeah. Clean this up just a little bit. All right. So I think we're about ready to flip the switch. If anything doesn't work in your circuit, just make sure you don't have anything that's not connected, right? The next big thing is we need something to measure the voltage. So we want to measure the voltage between 2 points. We're going to start the voltage measurement over here in the middle. And we'll put the end probe down here at the end of the circuit, okay? Leave your voltmeter there so it can show you what you got going on. And then of course, lastly, we want to see how much current's coming across the light bulb. And also at the beginning. Got what?
I don't got the other one.
What's the other one?
The other meter.
What's the other? Did you go into intro or did you go into lab?
It took me straight in.
Okay. You can switch to lab though. I mean, I told you lab. Okay, well, I don't know, but if you don't have the tools, that's because you didn't do lab.
So I'm gonna have to make all of them.
Yeah, right. Yeah, sorry. I told you stop sitting there daydreaming. He's not listening to me.
You don't got to either, do you?
I'm gonna take this day virtual lab.
Yeah. So I'm gonna leave this up here, and this recording will be available later. All right. But I'm gonna close the circuit.
You ain't got to do it.
Look, it say look right here. It say
So I'm gonna change the resistors just a little bit. So the first resistor will make the highest. We'll make it 120. The next resistor is gonna be half of that. So that's about what, 60. And then the last one's gonna be a fraction of that. So let's make it 30. It's okay, man. You can do it. Okay? And this recording will be available later, so trust me, you can always get it done later. You have, for this quiz, till tomorrow, 4 p.m. As I said, Tyler will be at the National Science Teachers Association Conference, which is actually started today, and it's going to be tomorrow and Saturday. So I'll be hanging out with other exquisitely smart scientists. Huh? It's where other science teachers from physics, biology, chemistry, they come from other states and other parts of the globe to Chicago. And we talk about different strategies and teach you guys STEM. So I'm going to be coming back with great ideas for next school year. Yeah, that's how I stay sharp. We go hang out with.
Good idea. Not CPS.
Well, actually, there's CPS teachers that'll be there too.
They not only teach us those type of. In 7th grade, my science teacher ain't teaching nothing.
Oh, he's fussing.
that's so loud. You said what grade?
7th grade.
Okay, so it's been 18 minutes on this now. We got to move to the we do. Make sure you take a screenshot. I just want to mention this. You're going to switch it to conventional like we use. These 2 screenshots. This one, then you're going to go to conventional and blueprint mode, and you take that screenshot. Those are the 2 we need. You don't what? Well, you don't need all the points then. But you'll notice that the current on the ammeters change based upon the level of resistances. And that's exactly what I wanted you to see. The current here should be, there we go. Okay. And you notice the main branch current is at 1.03 amps, all right? So you need 2 screenshots, one in electron mode like this and cartoon, and one in blueprint and conventional, all right? All right, so I'm about to get going onto your we do next. It's 12:36. I still got to do a lot of math with you, and then turn you loose to your you do exit slip. You have until, like I said again, you can watch this video tonight and do this part if you're behind, because I heard y'all was in the wrong section. But you can go back and review the video to do it on your own. All right, 2 screenshots needed in that section. Let me stop this.